Hi, so I'm Marta Musik. I work in SignalFX, a Splunk company here in Krakow. So SignalFX is a monitoring and tracing company. So whenever you see a screenshot on my slides, whenever I point to some examples, they will probably be coming from a SignalFX product. Though the presentation is not really related to the product. I mean, the concepts are quite universal, and I hope you'll find them useful also if you're using other tools. So I've been in the industry for like around 8 years, so that may not be that long. But those have been 8 interesting years. So in particular, I had the chance to be in a few teams that were either redesigning or writing from scratch application solutions based on microservices architecture. And something interesting happened. As they grow, we were really struggling with actually answering the question, what's going on? I mean, at one point, we actually had a tracing solutions in our application that was more expensive than the application itself. The costs were just, huge. So half a year ago, when I started to consider going to SignalFX, I was interested, and I started doing research. And actually, that's when I learned about this word, observability. And at first, I was skeptical. Like, it was difficult for me to get through all those buzzwords and to find actual technical content. But then, as I started to work and I started to solve some of those problems for other developers, I actually found it interesting and found some things that would really have helped me before. If I had known them 8 months ago, I wouldn't be struggling in my previous role. So that's basically why I'm here. So I want to save you this phase of being skeptical and to give you those things that I find valuable. So you may understand why I think there is observability hype. I mean, my career is basically intertwined with this topic. But is there something else going on? So from year 2013, we have Monitorama, which is a dedicated conference for monitoring and related topics. And actually, this year, it became a conference for observability practitioners. So it did officially change its name. Observability and also observability as a code started appearing on various lists, like top 10 trends of 2018-19. For example, ThoughtWorks Tech Radar. In Java world, there is this monitoring facade, Micrometer, which is a part of Spring Boot. Version 1.0 was released in 2018, so we now have production-ready code in Spring Boot. So yeah, I'm talking about observability. I'm proving to you that there is some sort of hype. But what is it? I haven't given you a definition. So that's actually the first reason for being skeptical. Maybe there is nothing about it. It's just plain old monitoring. So monitoring, so we push and collect metrics that give us information if something is wrong in the system. That's just plain old logging that we all use. And finally, that is tracing. So that's probably the part of the stack that it's most rarely used. How many of you work with tracing solutions day to day? Yeah, a few, but not most. So a trace is basically a record of transaction in the system. So we want to know how long a transaction takes in the system, how much time is spent in which part of the system, and tracing solution usually can show us that automatically. So those 3 are called 3 pillars of observability. And maybe, well, there's nothing more. There is a very vocal opposition that wouldn't agree with that. It's just the tooling, they say. The tooling itself doesn't give you any answers. So I like following measure of observability. So basically, if I want to know something about the system behavior, how likely it is for me to get my answer from the outputs I have at my disposal. And I'm like getting excited with the possibilities, opportunities that this question gives us. I mean, you can imagine product people using it, business people using it, you can imagine SRE using it, and so on and so on. But I think in our case, in case of developers, it usually boils down to the, what is the problem, where is the problem, and why is it? So yeah, I've given you tooling that you know and you use. I've given you question that you probably answer every day in your job, that you answer for years now. So still, what's going on about this observability thing? So let's find out. I have a demo prepared. So basically, my demo is a hello world in the world of microservices. So this will be a small Java application, which is based on Spring Boot Starter. It has micrometer enabled with default configs sending metrics to SignalFX. It's dockerized and it's deployed to Google Kubernetes Engine. Two replicas are deployed to Node cluster. What's there to know about such deployment? Yeah, so just to prove you that I'm not lying, that's the base REST controller. So I have 3 endpoints defined, just the main one, to show that the application lives. I have the endpoint compute that will hopefully trigger some CPU spike, and the endpoint allocate that will allocate some memory. And those endpoints are chosen this way because here I have a very simple dashboard. In the top left corner, you see JVM GC memory allocated. Below that, Eden. On the right-hand side, you see HTTP request rate and also CPU utilization per node. Not much is going on, so let me just send a few requests. It's just a simple GET request that's supposed to trigger some movement there. Let's wait for a minute. Yeah, that's the nervous part. I mean, will it spike? Yeah. So we do see the spike in HTTP request rate. That's the request that I've just sent. We do see the spike in memory here, and also some movement in CPU should follow. Let me maybe trigger a bit more. Yeah, so basically there's some movement. It's a very simple thing. It's just a hello world. So let me go back to the question: how much is there to know about such a simple application? So actually, if you start looking at it, even at the metrics that are reported, but so simple deployment, we do have around 4 metrics related to HTTP, 1 metric related to logging, 16 metrics reported by Tomcat server, which is running underneath. So in total, around 21 metrics reported from the application. Then there is 20 metrics being reported by JVM, 6 from Docker, 29 from Kubernetes, and some more from Google Kubernetes Engine. So in total, it's 196 metrics. And it seems that a metric is actually the most concise form of information we have about the deployment. That seems pretty big number for me, as for a hello world. But actually, what do I mean when I say metric? I mean, in the old days, we just had a key like computations and the number for it, 15 computations in this case. But we no longer have single applications, so now we need to prefix that. We have metric that is coming from a particular application. Then the virtualization happened, so we had multiple hosts. Then we added Docker. So you see where I'm going with it, and what a nightmare it would be now to change the order of those things, especially if you have it in dashboards or anywhere else. So the response of the industry was with a concept of dimensional metrics. So actually right now, metric is a combination of a metric name, in this case it's just CPU.percent, with a set of dimensions. A dimension is a key value pair. And to be precise, when I say metric, I mean usually the metric name. And the thing that is identified by this combination, which is actually a set of actual data points, it's called a metric time series. So that's how it looks like. So in this case, we have one metric, CPU.percent, being reported by a few sources. Those sources, marked in the red, are identified by the dimension plugin instance, which can have different values. So each of those sources, each instance, can be reporting that in a different way. So those are just some examples how that could look like. And in the end, you end up with a chart looking like that one. So you have a lot of lines. They all represent CPU.percent, but for different sources. So in that case, we have a chart that is showing 100 sources reporting this one CPU.percent metrics, and that's just a sample of over 2,000 available sources. So yeah, looking from that angle, our simple hello world deployment created 2 hosts, 19 pods, 31 containers, and almost more than 2,500 metric time series. For me, that's a bit shocking for a hello world. It's a big number. So yeah, that's my take on what happened. Why do we have this observability world movement need? Yeah, of course, the software does more and more complex things. We are right to expect more from it. But also the numbers of layers in the stack rose. I mean, right now we have it running in the cloud. We have many instances of containers. We have it being orchestrated, and service meshes are appearing. The places where the problem can be located are multiple and difficult to locate. The second thing that happened is that the number of entities is larger right now. So you do not monitor one single instance. You monitor hundreds or thousands of them. So if at that point you agree with me that the need for observability is a real need, it's not just something manufactured, out of thin air by marketing people, you may go and start Googling. And when you do, you will find a lot of those tools, libraries, solutions. For example, microservices, application performance monitoring tools, or cloud monitoring tools, or application monitoring tools. I mean, does that matter? Is that something that's, again, created just to sell us a new piece of software? Or is there something behind it? I mean, there can be. So in the world of microservices, there are 2 problems that we are unlikely to escape. First of those problems is called, let's say, high cardinality. So that means that there are dimensions being reported together with our metrics that can have many values. How much is many? I mean, from what I know currently, Prometheus recommends to keep the number of the possible values under 100. Is that possible in microservices world? It depends on your deployment. But with scale, you cannot escape the problem of high cardinality. I mean, the dimensions like container ID, pod ID, plugin instance ID, and so on, they are likely to have more than 100 possible values. And there is another problem, which is called high churn. That, in turn, means that the sources that are reporting given metrics are dying and appearing frequently. So you can see that represented on various charts. That's those lines ending rapidly or starting rapidly. That basically just means that the pod or the container died or started. And depending on how big and how dynamic your deployment is, that may become a problem. You have a lot of data that is no longer relevant, and it may be difficult to find those time series that you want. So how much of a problem that is? So those are numbers from actual product deployments that are used in production, coming from the systems that we monitor for our customers. So the first one is pretty small. I mean, it's only 904 metric names over here, so that's not much. You saw that our simple deployment was nearly 200 metric names. But apparently, they have a lot of sources reporting those metrics. As the number of active metric time series, so the actual series of data that are being sent to us, it's over 900,000. Then those sources are dying and appearing. So the number of total metric time series, all that they have ever reported to us, is over 200 millions. And that's just for a small deployment. Then there's the one in the middle, which is in the middle. And there is someone who is quite big. I mean, they managed to report 500,000 metric names to us. Fortunately for us, because we take care, of storage, they do not have that many sources, so only 25 times more. But even then, the number of total metric time series that we need to store for them is over 2.5 billion. So, yeah, it may matter that you have a solution that is dedicated for microservices. It may matter because it can give you better visualizations, it can give you better defaults, it can give you optimized storage and cope with those two problems. Or you need to cope with them yourself. Yeah, so you understand the need for observability, you agree with it, you start using a tool. And often there is a lot of frustration. I've seen people fighting observability tooling at the various fronts. And often, the reason is one of those few I'm going to show you. So first of all is lack of understanding of a concept that is called rollup or accumulation, depending on the tooling. It's sometimes well documented, sometimes it's just silent and happens somewhere in the background. So let me tell you what that is. So on this chart, we have a source marked with orange circles that is reporting a signal, some kind of metric, every second. But for some reason, we are able to store it or maybe to display it only every 5 seconds. So after every interval, after every 5 seconds, we need to decide on a function that will somehow aggregate, accumulate, roll up those 5 values we have in the interval and present them as one. So in this example, we'll be choosing the value to represent 5 data points every 5 seconds marked with those red rectangles. So let's apply one of the common rollups, average. So as you can see, if we stop at every 5th second of this signal, take 5 last measurements, count an average from them, the resulting signal is much more smoother. So really, looking for spikes or for amplitude on a signal that is processed this way may be pointless. Of course, depends on the context, but may be pointless, and I saw people frustrated in such cases. Another common rollup that's applied by the tooling, as I said, sometimes explicitly, sometimes silently, that's just the latest rollup. So you do not compute anything at all. You just take the value at every 5th second. So in this case, the resulting signal is completely flat. So it's even more pointless when you try to look for spikes or maybe amplitude on such chart. Yeah. So talking about confusing charts, here we have a chart that displays traces that were saved for some kind of transaction. So what we have on the x-axis is basically how long a transaction takes. So from 100 microseconds to 10 seconds. Here we have the number of samples that we actually saved. With the colorful triangles in the bottom, you have the percentiles marked. And I don't know, is this chart confusing to someone at this moment? Do you know what I mean? That's a fair point, but more precisely? Yeah, logarithmic scale as well. I saw someone over there. Okay, that's me doing a bad job explaining, probably. Anyway, I will try once again. So as I said, with colorful triangles, we have percentiles marked. So basically, the green triangle means that the 50% of the request is supposed to be shorter than the place marked here. The 50% is supported to be longer than that. And you can clearly see that's really not the case. We have much less of them over here and much more to the right. The same goes for the all other percentiles. So actually what happened here? So with sampling, with tracing, we always have a dilemma. So basically saving, retaining, recording all the traces is really not practical. I mean, the volume grows with the number of transactions in the system. So the more traffic we have, the more storage we need. That's really not going to scale. So what's the easiest thing to do? The easiest thing to do is just to save every 100, maybe 0.5% and so on. But that's a problem, because that, as it's random, it may easily cause us to overlook rare events. And those rare events are those which are most interesting to the developer. So the samples that are longer than the average, much longer than the average. The traces where you spend unusually long time in one place in your system. That's also what's interesting. So actually what happened here on this chart that shows, once again, it shows the number of traces of given length that have been saved. It comes from a solution that employs another sampling strategy, which gives you a preference for rare samples. So we won't be just randomly choosing to save every, 1% of the requests. But what's going to happen? We are going to wait until the request is completely processed and then see, was it unusual or was it usual? If we find it to be unusual for whatever reason, we'll save it. So that's why you actually see a lot of more saved samples on the right of the 50 percentile. So actually, if we tick this checkbox above, which says overlay observed count, so basically show me how many samples of given length you saved in total, and also here we have the logarithmic scales. Now the colorful triangles will make some sense. I mean, with the logarithmic scale, here you have, well, it's hard to say visually, but it's likely that right now it's 50% on each side of the triangle. Confusing chart, it's one thing. I mean, you are likely to have some time to look for them and try to understand. But even worse thing, confusing alerts that fire when you think they shouldn't. So here we have a source signal displayed with the orange circles once again. And we have the green thing that is the average. So in this case, we use the rolling window. So we do not count one value to represent 5 seconds, but, well, we do count, but we move the window. So it's not every 5th second, but it's every second, but looking at the 5 last values and applying the average. So that gives us this green line. And the red line is when we have the threshold for alert. That's when we get the alarm, when we get paged. And it works reasonably well for a signal like that, but that's what happens if we have very sparse signal. So in this case, we have only one instance of metric being reported right here. And for those 5 measurements here, we get the average being equal to the thing that was reported. And it may wake us up in the night. That's actually what happened to me. We had a deployment that was used only by people in one time zone. So usually we had a fairly decent traffic during the day, but in the night, no one used it. So one day when they did, that single transaction caused all the caches to be repopulated. And it took much longer than we expected and woke someone up. Okay, so you understand the need, you use some tooling, but still, there are people who get annoyed then that their code really gets polluted. So I try to keep this presentation quite practical and to give you like singular tips that you can actually use. But that's probably the one philosophical slide that I need to put here. So basically, that's the same discussion with test code in some places. So my take on that is that if you can't answer the question, how will I know that my feature works? You really can't ship the code. I mean, the observability has become a requirement to the same extent that testability is. So you just need to write the code, and it's not the worst kind of code. It's something you need there. Having said that, still there are some things that can help you. So first of all, rely on auto-instrumentation. What does it mean? I mean, the tooling has gone forward. In the last 2 years, things were developing very rapidly. So right now, you can easily find some things that will be automatically able to, for example, show you the map of the microservices based on the transactions going between them. You will be able to find the tooling that will show you traces, so how long transactions take, also how much time is spent in every service. So maybe there is no need to reinvent the wheel, just simply. But if you have to write some code and write it manually, then there are some design patterns that can help you. So basically there are 2 in the literature. One is called domain probe, and I think the name is coming from Martin Fowler's blog, and that's also where I would send you to read the details, though the gist is on the slide. So basically you create a class when you encapsulate all the observability-related logic. So if you need to call a logger, if you need to call the metric solution, if you need to trace a transaction, you put it there with method names that are more domain-related than technology-oriented. So in this case, we have the class instrumentation that encapsulates those 3 functionalities with method names like attempting computation, computation succeeded, computation failed, and in there, you write all the observability code. That simplifies testing, and the code is cleaner. The other pattern is called event-based observability, and it's also well documented on the blog. Okay, so I think it's pretty obvious to most of us that we are sending data to those solutions automatically by APIs. But there is like a huge part that is usually manual. That huge part consists of alerts, dashboards, and charts. So even if you have a lot of data and it's all reported in organized and nice way, it's not worth much if you can't visualize it, if you can't act on it. And this part, as I said, most teams I know, they do it manually, and there is a lot of problem with that. So first problem is accidental edits. So in one of my teams, especially in the time when we are just setting up the solutions, whenever I came to work and I saw a chart that didn't look how I expected it to, the first question was, is there something wrong with the system, or has somebody changed this chart? Either by accident or because they were experimenting. Another problems, those changes that are made in code are not reflected automatically in alerts or detectors, alarms. They are not reflected in charts. So what I mean, for example, a developer changes the name of the metric. And if that metric is not visualized directly, but as a part of some computation on a chart, it may be not that easy to realize that it's actually 0, just because someone changed the name and it doesn't exist anymore. It's difficult to review and to enforce as a part of a process. I mean, you review the code, and what then? You go to the system, you click through it, and the code is in review, so it's probably in some developer environment. When do you go to production to check if a person added it? The changes are obviously not captured anywhere. It's also difficult to back up. We had our adventures with Prometheus instance a few years ago, which was not correctly assigned some storage and so on. So long story short, we lost our dashboards and were left only with some XML backups, I think, which were not pleasant to deal with. It's difficult to recreate, to create in different contexts, and that happens a lot. So you create beautiful dashboards in one environment, you want them in another environment. Also, it's difficult to know which parts need to be changed. So, for example, if I'm splitting one service into 2, which charts need to be modified, which alerts needs to be modified. Then, it's tedious to share. It's difficult to standardize. I mean, you could use things like common color coding. So, for example, across the whole company, we agree that at some level we'll start using orange, and at some other level we'll start using red for notifying problems. But if you are doing charts and dashboards and alerts manually, it's really difficult to enforce or even to standardize such things. Is there a solution? So there is this trend called observability as a code, which actually, I think, boils down to the fact that the tooling has APIs for all those things. So there are APIs for creating charts, there are APIs for creating alerts, and there are APIs for creating dashboards. And a lot of those problems goes away, especially in big-scale organizations, if you can just put it under source control. So just to show you what I mean, here I have a Python script. What happens here is actually, first I'm not a Python developer, I admit, so please forgive me if I'm using the wrong language here. But that's the array of metrics we want to observe. Here we have a loop that will just create a chart object for each of those metrics. Then we have a call to another file where we want to create all those charts. And let me just show you the file. So here in the file, we actually just have a chart object with basic parameters. So the description, the name, some tagging, and we just issue a post request, HTTP post request to the solution to create this chart. So going back to the demo. So if I go to the dashboards here, you can see that here in the custom dashboard groups, I have only the very simple dashboard I've been showing you called JDD demo. And right now I'm going to run the script. What happens underneath is that a few HTTP requests were issued. And going back to the dashboards, yeah, there is another dashboard called Created with API, and it has those 6 charts I expected it to. So yeah, I get this is a simple example, not really impressive, but you can imagine the advantages it has when used in big-scale deployment organizations. Yeah, so those are the things I'd like you to take away from today. So first of all, in those dynamic and complex environments we now have, thanks to all the microservices movement, you won't get observability by accident. It may be actually quite difficult to find out what's going on. You need to think about it. The tooling can provide you with an advantage, especially if it's suited to your architecture. It can do some heavy lifting for you, like optimizing the storage, taking care of all those metric time series that are no longer needed, for example. And there are also many choices to be made where you implement monitoring, when you implement tracing. That may include sampling strategy, that may include roll-ups or accumulations. Choose wisely. It may be the case that choices are made for you, then just be aware of them, understand them. That can save you some frustration. Also, observability becomes as much of a requirement as testability, as performance. If there is code needed to achieve it, just write it with care. And finally, the observability tooling does support automation. Just use it. Use all those APIs. Look for those APIs in your products, and that may make your life much easier. That's all from me today. Thanks a lot.